A solar tower in Saudi Arabia achieved impressive results after it was able to generate electricity throughout the day without being restricted by sunlight, while significantly reducing the cost of construction. Solar towers depend on hot air rising to the top, different from solar panels that absorb light and convert it into electricity using photovoltaic materials, which is a well-known traditional technology for harvesting the sun's energy. Researchers from Qatar University and Al-Hussein Technical University in Jordan have found a way to double the electricity produced by a double solar tower, which can produce electricity throughout the day and night. This level of technology is not new. The so-called solar towers have been studied for rising airflow for more than 100 years, but researchers have made great progress by adding the secondary tower in Riyadh, using cold air in a downdraft. Building a dual solar tower has so far relied on simulations and weather data, but the results are promising. The project uses two towers 656 feet tall, one wrapping around the other. They are made of a material that can capture the sun's heat to warm the air at the bottom of the inner tower. The hot air drives the turbines as they rise. The diameter of the inner updraft tower is about 33 feet, and the diameter of the outer tower that surrounds it is about 45 feet. The space between the towers is divided into 10 channels. The double technology is being utilized after the hot air rises. This leads to the operation of the main turbine. The air is then sprayed with a fine, cooling mist. The cold air travels through the 10 channels, turning other turbines. Updraft towers are usually made of glass or other greenhouse materials that trap heat. The air is heated at ground level, and as it rises to the top of the tall tower, it spins a turbine to produce electricity. But the idea remains experimental. The costs of building large and tall glass towers are still prohibitive for mainstream use. That the new dual technology tower could reduce costs by producing more than double the electricity of previous designs. Its design requires the construction of a secondary tower around the inner tower. They emphasized that the dual nature of the tower could help make building expensive solar devices more feasible. A big advantage of this concept is that it operates after sunset, thanks to the cooling tower, and can operate day and night. Using a solar tower simulation combined with local weather data, the team estimated that it would generate a total of about 753 megawatt-hours of electricity per year, which is equivalent to about 214, the power of a traditional updraft solar tower. The external cooling towers will produce about 400 megawatts per hour. The internal heating tower works best during the day under the hot sun to generate about 350 megawatts per hour. The research team indicated that the technology works best in desert environments, as humidity impairs performance. The cooling tower was affected by seasonal fluctuations in temperature, among other obstacles.